V and in a circle of radius r, then we can say that the time period t will be equal to 2 pi r over v, or we can say v is equal to 2 pi r over t. अच्छा, you can make a photo. आप 10-10 मिनट की बना रहे हो ना? हाँ, लंबी ना करना, बहुत बड़ी हो जाती है फिर. हाँ, अच्छा, इस बिल्डिंग में प्रॉक्टर कौन है?
थिएटर की क्लास हो.
अच्छा, ये उसका काम हो रहा है. वाह जी वाह, दैट्स इंटरेस्टिंग. कहाँ 008? ये हमारे साथ. हाँ, राइट. सो दे आर प्रैक्टिसिंग समथिंग. ओके, इट्स अ वाइल्ड क्लास. नाइस. देखो, फिजिसिस्ट्स आर सो क्वाइट. But the theater people, it's very interesting. Yeah, they do interesting things. Okay, good. So in this case, we can write this as mu is equal to the charge multiplied by the factors we just defined, as we know the formulas. For example, IA and I is equal to E over T, and we know that A is equal to pi r squared. So we can combine these formulas to get this, and therefore E over 2 pi r over V into pi r squared can be equal to EVR over 2. And if L is the classical angular momentum, then L is equal to mVr, and Vr is equal to L divided by m. So substituting, we get mu is equal to E over 2 into L over m, and mu into E over 2m into L. So this was an explanation of the equation that you have in the book, which is 3.32, right? मोमेंट. तुम्हें नींद आ रही है? तुम्हारी तबीयत ठीक है?
बस मैं रात को
सोई नहीं हो? वैसे ठीक हो? सोया करो आप लोग. आई सी मेनी स्टूडेंट्स नॉट स्लीपिंग वेल, है ना? सो टेकिंग द ग्रेटेस्ट कंपोनेंट, दुर्दाना इज मोस्टली अटेंटिव. Of L. Now this is an explanation from page 32. Remember, the pages with the numbers 30s are normally from chapter number 2, right? And the pages with the numbers of 70s are chapter number 3. So I was talking about the topic on chapter number 3, but now I am using a formula for chapter number 2. So that's why I wrote it there. Okay. So I am referring to the pages from time to time, or the equation numbers, just so that when you study yourself, it's easy for you to follow. Okay. So we have this formula in page 36. In this case, you can see that ml, L is a subscript, is equal to plus L, which is equal to 0, 1, which has integer values, and therefore if we use this, then we get mu is equal to E over 2m into h bar L. So this is equal to E h bar over 2m into L. This is equation 3.33. And L in this case is the angular momentum quantum number of the orbit. Let's write this somewhere. L is the angular momentum quantum number of the orbit. Okay. And E h bar over 2m is called a magneton. So this is a term. Have you heard of a magneton before? Magneton पहले सुना हुआ है? Bohr magneton सुना, बिल्कुल सही. Yes, we have a Bohr magneton in when we talk about the atom as a whole, है ना? जब हम पूरे atom की बात करते हैं, तो we use the electron mass and obtain the Bohr magneton. So this is for an atomic model or an atomic orbital. अब atomic की जब हम बात करते हैं, electrons की बात करते हैं, it's an analogy. Okay, we come back to the nucleus later. Okay, so for the atomic orbital, we use the electron mass. And then we obtain the Bohr magneton. Okay, and we know that it is represented with mu b, and the value is given in many books and tables and so on, which is about this. Now putting in the proton mass, okay, we have the nuclear magneton. And in this case, mu n is equal to, again you can find this, I can also give it to you as a problem to find this value, okay, or you can also find it in books and literature and so on. What do you notice between mu n and mu b? वैसे देखने में what do you notice? हाँ? Is much less than mu b. So we note that mu n is much less than mu b. This is because of the difference in the masses when you calculate them, right? Okay. So under most circumstances, we have atomic magnetism plays a larger role than the nuclear magnetism. So, the equation that we just wrote, which is 3.33, we can write it in the form mu is equal to G L into mu n. So, in this case we have introduced a factor which is G L, and this is called the G factor, and it is associated with the orbital angular momentum